In third grade, we frequently decompose number to quickly add or subtract numbers together, such as adding 24 plus 46. Here are some possible strategies we have used. I added the 20 and the 40 to get 60. Since 4 plus 6 is 10, I added 10 to 60 to get 70. I decomposed 46 to 40 and 6. I added 24 and 6 to get 30. Last, I added 40 and 30 to get 70. I started with 24, then counted up 4 tens to 64, and added 6 more to 70. Let's extend our ideas of addition to add 147 plus 213 plus 26. Notice there are two different students who did two different things. How are these the same and how are they different? One may look more traditional to us than the other. They are alike in that they both add like place values. They are different in that one is recorded horizontally and one is recorded vertically. Also, one includes regrouping 10 ones into 1 10. Let's extend our ideas into addition and show how this strategy works with base 10 pieces. Here I have our base 10 blocks using one of our interactive virtual manipulatives. So I need to start with 147. 1, 2, 3, 4, 5, 6, 7. I need to add 213. And I need to add 20. I see that in my ones column, I have a bunch of tens that I could gather up to regroup into tens. I'm going to do that. And I have 1, 2, 3, 4, 5, 6, 7, 8. So I don't have enough to regroup my tens to 100. So overall, I have 386 pieces. Would you believe there is yet another strategy we could use called partial sums to add? So let's add 147 to 13 plus 26 using partial sums. When I add 7 plus 3 plus 6, I get 16. Notice I did not carry the 1 where we typically would carry in our traditional algorithm. Then I move to my tens. 40 plus 10 plus 20 gives me 70. And now I move to my hundreds category. 100 plus 200 is 300. Now I can add vertically. 386. Let's compare 2,135 plus 462 using partial sums and the standard algorithm. On the left, we will use partial sums, and on the right, we will use the standard algorithm. So our first step with partial sums is that we want to add 5 plus 2, which is 7. Similarly, the standard algorithm is the same. We start on the far right. Now, with the partial sums, I'm going to move to my tens category. I will add 30 plus 70, which is 100. Now using the standard algorithm, 3 plus 7 is 10, so I have the 0 and I carry the 1. Now I will move to my hundreds category. 100 plus 600 is 700. However, with the standard algorithm, I add 6 plus 1 plus the 1 we carried, which is 8. Finally, with partial sums, I will add the thousands. 2,000 plus 4,000 is 6,000, and 4 plus 2 is 6. Now that I have them all labeled on the partial sums, I can add straight down, giving me 6,807. Although it seems like many steps, it still gets us the same place. Match each number sentence to the student's verbal explanation of 155 minus 68. Take a moment to draw arrows to the correct one. Michael added to get the answer. His would be 68 plus how many gives me 155. Danielle decomposed 155 and 68, then he subtracted the decomposed numbers. And finally, Alexa counted backwards from 155 until she found the correct solution. Two students solved 234 minus 145 differently. On the left, you will see the student decomposed her numbers, regrouped them, and subtracted, whereas the student on the right regrouped as needed and subtracted using the standard algorithm. So let's use base 10 pieces to show how this is completed. We know what we know about place value allows us to subtract efficiently, and what we know about whole numbers can be decomposed as a strategy for subtracting and yet still retain their value. Let's review how we use our base 10 pieces. Start with 234. Need to subtract 145. I don't have enough ones, so I'm going to take one of my tens and regroup it to a bunch of ones. Now I can take away 3, 4, 5. I can take away 5 ones. I also need to take away 40 tens or 4 tens. I don't have enough, so I need to regroup one of my hundreds into 10 tens. So now I can take away 40. 1, 2, 3, 4. And I still need to take away 100. So I'm left with 89. Let's solve 326 minus 247 using base 10 pieces to show the steps of the standard algorithm. Take a moment to use your own base 10 pieces to follow the steps. Pause the video and we'll talk about it. You found that you didn't have enough ones in 326 to take away 7 ones. So you borrowed 1 from 2, giving us 10 ones, so 16 minus 7, which is 9. Now we only had 1 10 left over, which I need to subtract 4 from. I don't have enough, so we would borrow 1 from the hundreds, leaving me 2 hundreds, and now I have 11 tens, and 11 tens minus 4 tens is 7. Finally, 2 minus 2 would give us 0, so 79.